Reproductive isolation by Dylan and Mikey. This is a whole grainous cerealis species. They have many different appearances and they live in a desert environment where it is often very hot. The local predators are the Dogus plasticus species, and they are definitely not afraid to eat the whole grainous cerealis. The heat forces the cerealis to stay in the shade for most of the day, which then makes them a more nocturnal species because of the cooler nights. In turn, they reproduce at night as well. Every day, reproduction continues, filling the environment even more. The Dogus plasticus continues to eat the cerealis every day as well. Surprisingly, a rare storm comes with so much rain that it changes the environment. The river fills again. Some of the cerealis get stuck on the other side of the river because of the flash flood. The environment is completely changed by the rain in a matter of days, and there's a surplus of food and water by the river. Therefore, the cerealis and Dogus plasticus come to the river for their food and water. The moisture and coolness by the river allows the cerealis living in the area to become day dwellers. The predators are still active at night, so the cerealis could reproduce during the day, giving a high chance of survival. Because of the light color of the sand, the darker cerealis is easily picked off by the Dogus plasticus. The darker foliage of the river environment allows the lighter cerealis to be picked off by the Dogus plasticus. Natural selection is shown by the cerealis with the favorable traits surviving. To help blend into the desert environment, the cerealis slims and becomes lighter. The same thing happens with the dark cerealis, but opposite. This is when reproductive isolation occurs. Both populations reproduce at different times so that they cannot reproduce together. Genetic material is almost never exchanged between the populations, and the subspecies will only survive by reproducing with themselves.
One eternity later.
After many years, the subspecies have no chance of breeding because of the amount of changes that have occurred. There are now officially two different species by the theory of reproductive isolation. The original population had many different variations and colors. The later desert variety was light-colored and slim so that they have a higher chance of survival in their environment. And the later creek-dwelling variety was dark-colored and large to blend in with their environment so that they had a higher chance of survival. Wholegrainous cerealis grew into two different species because of the two different environments that were created. Prezygotic isolation was shown when the river created a barrier between some of the wholegrainous cerealis population. Postzygotic isolation was shown when they grew into two different species and tried to mate but could not. Gene flow was shown when some of the wholegrainous cerealis population moved to the river environment but some did not. Directional selection was shown when the darker cerealis moved to the creek area where it blended in easier, while the lighter cerealis stayed in the desert where it blended in easier. Allopatric speciation was shown when the river geographically isolated the population of cerealis. Sympatric speciation is when a population of a species that shares the same habitat become reproductively isolated.